Ocean changes almost starved Earth life of oxygen. Chemical changes in the oceans more than 800 million years ago almost destroyed the oxygen-rich atmosphere that paved the way for complex life on Earth, new research suggests. Then, as now, the planet had an oxidizing atmosphere, driven by phytoplankton, the plants of the ocean, releasing oxygen during photosynthesis. However, new research from an international team including the University of Exeter and spanning Toulouse, Leeds, London and Nanjing, suggests ocean changes in the early Neoproterozoic era, from 1 billion to 800 million years ago, may have locked away phosphorus, a vital nutrient for life, limiting phytoplankton growth and oxygen release. The study suggests the amount of phosphorus available remained just sufficient to support the oxidizing atmosphere, preventing a return to the reducing, oxygen-poor, atmosphere that existed over a billion years earlier. Ocean chemistry in this period changed to become ferruginous, rich in iron, said Dr. Romain Guilbaud, of CNRS, Toulouse. We know ocean chemistry affects the cycle of phosphorus, but the impact on phosphorus availability at this time hadn't been investigated until now. By analyzing ocean sediments, we found that iron minerals were very effective at removing phosphorus from the water. Phytoplankton growth also boosts atmospheric oxygen because, having split carbon and oxygen and released the oxygen, plants dying the carbon is buried, so it cannot recombine with oxygen to form carbon dioxide. Despite reductions in photosynthesis and this organic burial of carbon, both due to limited phosphorus, the study suggests oxygen in the atmosphere dropped no lower than 1% of current levels, just enough to maintain an oxidizing atmosphere. Our observations suggest significant potential variability in atmospheric oxygen concentrations across Earth's middle age, said Professor Tim Lenton, director of the Global Systems Institute at the University of Exeter. He added, "One question about the emergence of complex life is why it didn't happen sooner. Lack of oxygen and lack of nutrients are two possible reasons, and our study suggests both of these may have been the case in the early Neoproterozoic era. In fact, if phosphorus levels in the water dropped any lower, it could have tipped the world back into a reducing atmosphere suitable for bacteria but not for complex life. A return to a reducing atmosphere would have reversed the Great Oxidation event, which occurred about 2.5 billion years ago, during which photosynthesis by cyanobacteria in the oceans introduced free oxygen to the atmosphere." The study, which used samples from the Huainan Basin in North China, was funded by the Natural Environment Research Council, NERC, and the National Science Foundation of China. The paper, published in the journal Nature Geoscience, is entitled, "Phosphorus-limited conditions in the early Neoproterozoic ocean maintained low levels of atmospheric oxygen." The Global Systems Institute aims to work with others to secure a flourishing future for humanity as an integral part of a life-sustaining Earth system. Please save the trees and nature. Please subscribe my channel. Thank you.